Hey everyone. Uh, so tonight I'm just going to have a look at RubyGem vulnerabilities and in particular some tooling that I use to try and find them. This is pretty open-ended, like I don't really have anything planned. This could just be a complete disaster. I might just give up. Or we might find a CVE-worthy exploit. It's a pretty wide spectrum there. Um, so the first thing I'm going to talk about is the data we have available. And I just finished migrating Postgres from version 11 point something to 11 point a little bit higher. And so I now have the data set back in my hands. This is a data set I exported last year. So Ruby Gems, there's actually a dump you can pull down that has all of their download counts, gems, all that kind of information is available. So let's have a quick look at that. Now what I've got here is I've got some baked tasks which I whipped up earlier. And one of the ones is this one called statistics, which I was quite interested. One of the things that annoys me about RubyGems a little bit is just how much junk there is in that system. And that's not because I don't think there should be junk. It's just that the signal to noise ratio is quite bad, which I think makes it tricky for new users. Is this gem maintained? Can I use it? Yada yada yada. So this is I was just for my own purpose. I was kind of interested in the statistics. Awesome flickering and slag. One day NVIDIA will solve their driver problems on Linux. Right, so let's chuck that over there. This statistics task, what it does is it pulls out data from the database and it looks at the distribution of gems based on download counts. So it looks at, I've limited my search to the top 10,000 gems, and all I was interested in is what proportion of downloads that represents and what the spread looks like. So I'm going to go ahead and run that. I've already run it earlier, but I can run it again. And what we find is that the top 10,000 gems represents 6% of all gems in the database, but it accounts for 64% of all downloads, which to me is massively lopsided. And what that looks like is this. So this is the graph that was produced from that data, and this is a histogram of download counts, and these bins are 10 gems wide. So each bin represents 10 gems in order of popularity, and this axis, I think it should represent download count. It's been a while since I actually wrote this code, and it's just incredible that the top 10 gems, represents almost twice as much as the top 30. As that third bin. And then by the time you get out to the top 50, you're just out in the weeds. There's nothing, it's just crazy. So this is the top 500 gem, I should say, because this is multiplied by 10. These bins are 10 wide. But it's just amazing. Like the top 2,000 gems, if you look at this further out, I gave up trying to auto scale this because the tail is huge. Let's just run that again. So that's in theory the top 10,000 gems, and you can't see anything at that part of the scale. Actually, it scaled this axis as well. I didn't want that. Oh no, it hasn't. It goes from 0 to 10 to the 9. Okay, that's pretty epic. Okay, so I guess what this tells me from a security point of view is that I don't have to look very far to find security issues, because if I'm concerned about gems that people are actually using, looking in the top 10,000 gems is going to give me 64% of all downloads. And so that was kind of my hypothesis that I wanted to check, that how many gems would I have to actually look at to figure out, whether is worth trying to figure out if he has exploit or not. Oh yeah, it's all my test directories. So what I did was I made another task where I basically just downloaded. Actually, opening this in Atom is a really bad idea. So these are all the gems organized by 3-letter prefix. Right, so you have all the async gems, some of them, most of them, the ones that I released last year, are in there. Like Rails isn't in there somewhere. And so I literally have all the source code for the top 10,000 gems in this directory. And the next thing that I was interested in was how many of those actually have code that would be worth trying to exploit. Because some of these gems don't have a lib directory. I can't see any here, but a bunch of them don't. And so I think that's what this task does. I should have written documentation. Let's try running it and see what happens. This hilarious. The task is called list, and Bake has a list command. So what this one does is it looks through the first 100 gems I've put there. And what it does is it tries to identify gems which potentially using thread primitives, thread, mutex, and synchronize in this case. There's other ones you can search for, but these ones had quite a good hit ratio. And so what it does is, maybe I should just not print out the ones that don't have anything, but so this tells me in RSpec mocks there's 6 instances of the keyword mutex and 11 of .synchronize. So these kind of things tell you whether there's a chance of some kind of issue. So lock and unlock might be more likely to have issues. Now I have scraped through obviously this top 100 list. So let's maybe go out to top 1000 and let's actually ignore it if it doesn't generate any hits on these keywords. So let's modify this code a little bit. Compute the sum, go through all the source files, see if they match that stuff, and unless it's empty, print it out. Okay, so we're just going to put it there. And then now gem thread. It has 47 mentions of thread. That makes sense. Okay. So at this point, it's just really a stab in the dark, looking at stuff which you think that could be written badly. And it's surprisingly not that hard to find. I mean, if you look at the code, let's just pick one. Like InfluxDB has 14 million downloads and it has mutex, synchronize, and thread. So, like, honestly, I don't think InfluxDB is a commercial software, so the chance of that having something vaguely exploitable is probably low. But let's have a look at it. Oh, come on. Why did I print out path with the absolute? Oh, great, the flickering stopped. Okay, excellent. Okay, so just to preface to this, if I do something CVE worthy, I will probably just terminate the stream because I think it's I don't want to go down that path. I don't want to be on the receiving end of like, why didn't you do this privately first? So let's have a look at those usage of mutex. They put it into a constant. That's a bit scary. So one of the problems with this is as soon as you see this, you know, they've got a global log, and you know, you sort of wonder why that isn't per instance or per thread, or sorry, like per instance of what this stuff is doing. So it's kind of quite strange to see that. So let's have a look. They've got a mutex, they're synchronizing, and so this immediately looks suspicious to me because they're returning it here and there's no synchron. They're not locking that. I mean, the chance of this being a problem in CRuby with the GIL is low, but if this was some code in C, there's every chance that one thread comes in here and locks the mutex and does this line, and then another thread comes in here and says like half a pointer, you know, it does this conditional check and says like, okay, there was something in there, and then returns it. And there's if you have something which is bigger than a machine word, that can cause problems. You know, you can get the low half or the high half written independently in a way which can cause issues. So that is kind of and you see this as well. I've seen this quite a few times. People just assume that they should double check. You know, actually this code would just be way better like that. It's like, okay, let's optimize this method by returning the worker if it's been constructed already. It's like some kind of fast path. But the crazy thing is, like, an uncontained mutex is super fast anyway, so that's suspect. So what I would normally do now is I would pull this code out into isolation. Like, I would just probably not this exact piece of code, but then I would try and break it in CRuby or JRuby. JRuby is a little bit easier to break things with because it actually has real threads, so the chance of like something collapsing is pretty high. So that's like not great. It's not that great. There could be something in there. Let's have a look. There was a couple of other things. So they're creating a bunch of threads, and what are they doing with their threads? Threads are a great candidate for problems because as soon as you have any shared mutable state, the chance of that causing some kind of disaster is just so high. In my experience, I guess I should say that. So they're creating a bunch of workers. Actually, I want to check one more thing. Synchronize. And what I might do is, rather than focusing on specific issue, because I think what I did do when I did find those exploits before is I think there's something here. I would put it in a list to come back and visit if I had like a bunch of time. But you know, I think it's probably the chance of finding something is low-ish. But what I want to check is whether worker is used in any other context, like what context is it used in? Because if they were using this instance variable or assigning to it anywhere else without a synchronized block, that would be an immediate thread safety issue. But I can't see anything really obvious, like they're not exposing it. I guess the other thing is you have to consider if worker itself is thread safe, because obviously this is designed to be called in the context of multiple threads. So is worker itself thread safe. What is worker? Okay, it's this thing here. Client queue threads, blah, 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 blah. What kind of crappy code is this? It's going through like all the threads in the system and then checking if they belong to this object. It's just weird. You think they just have an instance variable or something? What they do? I don't know what they're doing. Until client.stop, check background queue thread number, sleep random sleep interval. Oh, awesome. So let's just move on. There's nothing really low hanging there. We'll find another one to have a look at. I mean, I'm more happy to just go wide and shallow on this talk, because I think that if you're interested in doing this, it's more a matter of maybe I can show you some of the ideas behind it rather than specifically identify something. But, you know, if we do find something, it will be exciting too, so. I don't know what honey badger is. I know what a honey badger is. I don't know what this gem does. Let me try like changing the vsync settings again. That might have helped. Who knows? No, it didn't. Oh well. Alright, this is the notifier gem for integrating apps with the Zap Honeybadger exception notifier for Ruby on Rails. When an uncaught exception occurs, Honeybadger will post the relevant data to the Honeybadger service specified in your environment. Okay, seems reasonable. A lot of mutexes. Mutices, I don't know what to call them. Okay, context manager, include conversations, self.current, thread.current, that or equals new. That's bad. Is it bad? I think it's okay, but it is fiber local, not thread local, which is funny. So if you use this inside an enumerator, it would break, or like anything that uses a fiber. Okay, so let's have a look at this. We make a new mutex, and what are we protecting? This. Why would you create underscore initialize? Okay, set context, mutex synchronize, context or equals empty hash, context update. Okay, so is this context ever used outside of the mutex? I don't quite understand. Obviously they've tried to synchronize it, so they're not gonna, so these methods will run in lockstep, but once you return the context, that's not thread safe anymore if you were trying to if you want to try and manipulate it. Okay, set rackham, mutex synchronizer, that seems okay. Initialize, set that stuff to nil. I'm interested in how get context is being used. So it looks like they are pulling that out and putting it into this global context thing. And I guess my concern is that if they're assuming that that context should be thread safe, but then they're manipulating it somewhere else. I can't even see where it's being used. I don't even know what this object is for. So far it's an empty hash table with a bunch of stuff merged into it. Let's have a look and see if there's anything else interesting. Worker. Okay, worker. Oh, this is more complicated. Subclass thread, so we have a named thread, useful for debugging in thread.list. Ah, that makes sense. Right, def initialize config mutex muse. What are they protecting with mutex? Mutex.synchronize shutdown equals true. Is that it? Shutdown equals false. Data equals no, return true if the thread is alive. Otherwise, make a thread and call run. Shutdown, synchronize, shutdown, suspended, synchronize data. Okay. This kind of code has a race condition because it's calling synchronize twice. Shutdown and suspended are called one after the other, and the state might change in between those two calls. So you might get here and say, I haven't shut down, but then you might get here and it has shut down, but it's not suspended. And then you return true. It's like, confusing. Dangerous, but I do that too sometimes, so. There's nothing really striking me as low-hanging fruit for exploiting. So let's have a look at another gem. So I did this for a week, and then I found about 5 to 10 different exploits, which I talked about in the Ruby World Conference 2009 talk, and I just picked the ones that were the most easy to explain. Rat contrib. It's probably just some locking middleware. Twitter. Google Cloud Storage. GraphQL. Oh, that would be funny. Semaphore equals mutex.new. That's pretty epic. What the concurrent-ish map. It's hilarious. I don't know what it is when you go looking through code that uses thread primitives and you just see stuff like this. I mean, all the gems we've looked at so far, which I've basically just picked at random, have just, I don't know. Concurrent-ish. What does that even mean? Okay. So we've got a semaphore. Technically this should be under the technically this should be under the mutex too, but I know it's only used when the lock is already acquired. It's epic. Thread safety. Semaphore equals mutex.new, storage equals empty hash table, set key to value, semaphore.synchronize storage key equals value, compute if absent key. So this is just like a lazy initialization. If the key doesn't exist yet, it will compute it, and it does it all side in a lock so that someone else can't do it at the same time. That looks okay. That looks okay as well. Storage equals other dot copy storage. Let's have a look at where it's actually used. Concurrent-ish map. So it's just a giant hack when they don't have concurrent map available. Okay. Lazy method map. So like the chance of this actually being a problem in production, as long as you use concurrent Ruby, then you don't have a problem. But then this is also an issue when you see code like this and you think, well, is this code path tested? You know, is anyone actually, is it always running with concurrent map, or is this just something which can happen from time to time? Storage equals use concurrent. Okay. It's good to see they're actually like duplicating it so they don't end up with shared storage, and the duplication looked like it was implemented correctly, which is good. Computer absence. This looks relatively straightforward. Set lazy class lazy value method. Get computer absent value class. Find superclass method. That does look okay. So that's what they were saying. This method, find superclass method, it calls storage to each pair, and that doesn't have any locking, but it looks like they've made that private and it's only used inside that which is locked. So that's kind of okay, except in the case where someone comes along and updates the code and doesn't realize that. But that seems okay at face value. What was that one? Why were there two mutex in this class? Oh, right, it was just that. That could have been more exciting, but it wasn't. What else is exciting? The ones that are generally more exciting would use mutex. Just having mentions of thread is less exciting. Mongoid. Synchronize 2, mutex 2. Thread 114. Memoizable. Chef. That looks pretty busy. Let's have a look at that. That's crazy. They have like a Win32 implementation of mutex for some reason. That's pretty insane. I like it. I'm not sure what they're doing with that. What are they protecting with this mutex? This is actually pretty tricky multi-threading. They got conditions, mutex, everything. So that can be racy. But I assume that's expected. Win32 Damon. So, another Rand. Some of these methods, you look at them and you think, okay, startup parameters, is that something which is shared state? This one is quite a tricky analysis to do at 1 a.m. in the morning. Why do they have this? Are they looking around output? Print, semaphore synchronize. This is interesting. Yeah. Not very practical. Oh yeah, I don't feel like digging into the Win32 API, so let's forget about that. What else could we have a look at? CocoaPods. No, that's unexciting. Bootsnap. Well, it's got a scary name, so maybe. Crap. Remove once Ruby 2.2 support is dropped. Well, it's end of line. Okay, what's it protecting? It is protecting an instance variable called dirs. Where is that initialized? Reinitialize, okay, here. I once heard that in Rubinius, if you assign to an instance variable from multiple threads, the state of the internal object could actually get corrupted and the instance variables could literally disappear, which I thought was pretty funny. And I think it's unlikely this is a case, but dirs is definitely not initialized in the constructor. So this is actually it's actually easier for Ruby to optimize the structure of the class, I believe, if stuff is initialized in the initializer rather than lazily done like this. But let's have a look. So it's predicting path, object, index, dirs generated at. So anything used outside the synchronized block. So that's another one of those kind of like questionable optimizations, because this is assigned inside a synchronized block and yet it's used outside a synchronized block. And so with CRuby that's totally okay, but in JRuby there's every chance that could cause an issue. I don't actually know the JRuby memory model, I just know that it's less forgiving. And this is essentially a synchronized write but an unsynchronized read. Ruby's pretty forgiving. But if you were doing this in another language like C, if this was like a string copy, like string n copy, then you might end up with half of a path copied into this object, you know, this string, and then you're comparing it here, and it's not valid at that point. I mean, if for some really unlucky reason that was a string buffer with like 8 characters, and that was a string buffer with 20 characters, and so you overwrote the null placeholder while you were doing the string copy, and then you tried to do this comparison, it was just like this string just goes forever. Like, yeah, that's potentially an issue. But again, like Ruby's pretty forgiving, so probably not an issue here. So it's doing a bunch of stuff outside the synchronize block. Reinitialize if that stuff. The other interesting thing to look for is deadlocks, and maybe we can look for that next. A deadlock can be easily constructed if you have a statement like yield in here. And if the code is not put together correctly, if you try and call another method which has like mutex.synchronize while you're inside a block that has been synchronized, you'll cause a deadlock. And I've seen that a couple of times. Actually, there is an example in the AWS gem, but actually triggering it is pretty tricky. But it still is an example of a deadlock, which is caused by the fact that if you hold a mutex for a long time and you do a bunch of stuff in it, it's just generally bad. And especially calling user code, like just arbitrary code, while you're holding a mutex is just generally a bad idea. So let's have a look at what this stuff is doing. Reinitialize was okay. Feature equals feature 2s, absolute path feature. What does that do? It's not very exciting. Loaded features index, loaded path cache. Okay, here's another one of these things. It's pretty interesting. We've seen quite a few models where basically what the user wants is a key value, like a multi-thread, like a thread-safe key value store of some sort. And that is very, very common. And it is correctly implemented by concurrent Ruby, and yet so many code roll their own and pretty much like have minor issues or outright bugs. So let's have a look. Remove, okay. Transaction mutex equals mutex new data equals false, load data, store path equals store. Okay, so it looks like it's loading something from disk maybe. What is store path? Oh, sorry, it's an argument. What does load data do? Data equals begin message pack load file bin read store path. And it returns a either that or just an empty hash table. What the hell is the point of that? Oh. Okay. Oh, there we go. So that's easy enough to deadlock. Like you can deadlock that code, no problem. They've even got it here. They throw the exception, nested transaction error, if the mutex is already acquired. So it just blows up. So I guess it's okay. I mean, a deadlock blows up with an exception of Ruby too, so it's not particularly bad. But I guess the problem that I have with this is, what does own do? Does that just mean it's owned by someone? Hold on. Then okay, so it returns true if it's owned by the current thread that's executing. So fetching seems to work because they're guarding that with that transaction mutex. Setting it seems to work. That seems to work. But again, here we've got a read potentially outside of a transaction because there's nothing enforcing. There's no like, I mean, they've obviously gone to the trouble here of checking that the current thread has opened a transaction, but there's nothing protecting this here. Now I actually showed an example of this in JRuby failing. It's entirely possible that the data structure is being updated, like hash table, while you try and do this. It's like this operation is not atomic. Internally, it's computing a hash table bin and then doing an index into that, and then potentially, if it's a open or closed addressing, depending on the implementation, it could be scanning a linked list to find the specific item. And so if you're doing this at the same time you are doing like that, I mean, this operation, if your hash table is full, this could reallocate and re-index all the hash table items. Imagine if that happens in lockstep of this operation, which is computing a bin index and then trying to look up the item. I mean, at some point, the memory could just even be invalid. You know, that could be like, okay, I've got this, the C code for this could be, okay, I'm going to get a pointer to the internal data structure. And then this operation could then like free it and allocate a new one because it's resizing or something. You know, the fact that this works is just pure luck, really. So it's not really good. You know, they should just, it's one of these things, people just think read operations are safe. I don't get it. Like, to me, like, it's completely crazy, but, you know, let's protect the write operations. In fact, this read operation here seems to be protected because it's a fetch or set that's actually doing a write. Internally, it's calling yield, whereas this is pure read operation, but it's not safe at all. So yeah, that's pretty bad. And I guess it, you know, if you dug into this and looked at how it was used, then either it could be like a denial of service attack, or you might even get something more elaborate. You know, if you can cause corruption in internal data structure. I don't know if you've looked at some of the JavaScript hacks for escaping from the JavaScript, or actually it might have been Java, the one that I saw recently. All it took was to get a class to have an object instance interpreted as a different kind of class with different member instance variables. And by doing that, you could basically walk through the entire address space pulling out data, including like data which is the security related instances of like classes that you shouldn't be able to call methods in from, like, say, a web API. So it's pretty crazy seeing stuff like this. You know, in Ruby it's probably okay, but that's a big if. Hey, let's have a look at maybe like one or two more. RMagic. I don't want to look at the RMagic source code. CocoaPods, that doesn't look exciting. SQL. Oh no. Synchronize 132, mutex 9, thread 35. Wow, that's pretty epic. Sorry, Jeremy, I'm going to have a look at your code. has such good documentation that all those keywords were just basically documentation. I trust Jeremy to have probably done a pretty decent job. But you never know. I think the problem with writing thread safe code is it just takes one mistake. And it doesn't matter how good everything else is. It only takes one mistake. This is interesting. So I've seen code like this before where the mutex, actually I talked about it in the Ruby World conference talk, like having lazily initialized mutexes. Maybe I should just rip through source code for like this. I feel like that would be a really good idea, actually. We might find an instant hint. Why has my file listing disappeared? That was weird. Okay. I'm looking in the code. List. I wonder if we get any hints. Is that actually a valid regular expression? The vertical bars, they mean or. I have to like escape it. I think that's okay. Oh no. Oh no. Okay, let's have a look at Cucumber. I hope they put a mutex around their mutex. Like I said, like if this turns into a CV worthy event, I'm gonna finish. I'm not gonna like. Oh, it's like already too late, I guess. But oh no. Oh no. That's bad. At least it's only a pipe that's doing formatting or something. I mean, I just look at code like this, I'm just like, yeah, sorry, you can hardly see it because it's, yeah, my face. I'll just do that. There we go. It's like, yeah, let's just lazy initialize the mutex because, like, we need to save. We use it everywhere, but let's just still lazy initialize it because we might not use it. I don't know. Like, I mean, this is a pipe. Writing should be the primary operation. So if you have 10 threads call this method, then you get 10 mutexes. You can't complain about that, can you? Ouch. Hey, what else? Maybe it isn't the AWS SDK. I'm not gonna look. Someone else can look at that code. I'm not looking at that. I'm sorry. I mean, this is just bad news. Lazy initializing a mutex is just never good. I should have looked for that at the start. It would have been more hilarious. So, look, so for someone who's interested in going through and making issues, there you go. I'm really happy to put this code that I've thrown together online. And I did actually play around with slightly more advanced ways of trying to find issues. Actually, this one here I was interested to know how many gems proportionally use these things, because I was just interested, like, out of all the gems in the RubyGems repository, like what percentage we're using them. Because I just see it as such a huge risk. So I would be cautious of using any gem which uses thread mutex semaphore condition variable without actually auditing it personally, because if AWS can't get it right, and I guess that's AWS SDK v1, which maybe isn't used anymore, what hope do the rest of the developers have? I mean, even I stuff it up. I've stuffed it up from time to time, and I know what I'm trying to avoid, and it's just easy. It only takes one mistake. So I will put this code online, and you need to load the Postgres dump, and I think there's that file there that does it. I think that downloads the latest copy of the gems, and then it'll be a bake task, and you just run bake fetch, and that downloads the source code as fast as possible for all those gems. You're going to end up with quite a big directory. That's going to take forever. No, it's not. 12 gigabytes of source code and other crap. Yeah, and then I think you just need to figure out what kind of patterns, like that one or that one, and just look through the code and have a good look for, I guess the main one would just be a mutex which is protecting a resource, and then that resource not being used inside you being used. So read's a very common operation outside of mutex, as we've seen. People somehow think it's safe and it's not. Lazy initialization, race conditions, looking for yield inside synchronized blocks. I mean, the point of a mutex is to access a shared resource, but if you are acquiring a mutex and then calling user code, you are doing something horribly, horribly wrong. If you have user code that takes 30 seconds to execute, think about what that's going to do for the throughput of your system. For the correct implementation of the concurrent map, which has a cache, is to lock the cache, check if the key exists. If it doesn't, then unlock, yield, then lock again, and then do an optimistic insert. So you see this code is just so horribly broken on so many levels, which is super unfortunate. So I will throw this code online. Happy bug hunting, and I'm sorry if it's depressing at the same time. It's that's depressing, that list there. I didn't even think about it. So anyway, good night.